Well, good afternoon, everyone, and welcome to the Tuesday, October the 22nd, 2024 session in our series on innovation in manufacturing and supply chains in Asia. How things are responding to the needs for realignment. For those of you who are not usually with us, I'm Richard Dasher. I direct the U.S. Asia Technology Management Center. We're the primary producer of this series of weekly seminars that are available to students for university credit, and they're also open to the public. And we would very much like for our two audiences to stay around at the end of the seminar and get to meet each other. So today is a very special session in our seminar series. I'd want to thank Thai Silicon Valley for their help in publicizing the seminars. And to talk just a little bit about Thai, we have Mr. Ajay Manglani, who is the Chief Operating Officer for Thai Silicon Valley. Ajay, the floor is yours.
Thank you. Good afternoon, everyone. Such a pleasure to be here at the US ATMC Center. Like Dr. Dasher mentioned, I come from Thai Silicon Valley. Let me start by asking you a couple of things. What is common between 25,000 entrepreneurs, over 1 trillion in wealth created, over 32 years of history? If you do not know that, that is the impact that Thai has created globally. And we at Thai Silicon Valley are very proud and humbled to say that we are the founding chapter of Thai. Today, we are over 60 chapters globally, and number of different charter members, over 3,500 and tens of thousands of members. Over 32 years, our mission has remained very constant, which is fostering entrepreneurship. What does it mean is through 5 pillars, we help entrepreneurs at every stage of their journey, from educating to mentoring, accelerating to networking and incubating. We provide different programs to them. Some of them are like this, the Thought Leadership Series, where Dr. Paulraj and Professor Dasher will come together and share their wisdom. Others are like Funding Fridays, Investment Days, as well as VC and angel investment opportunities. Others are go-to-market accelerators, as well as different programs that we have designed to fund entrepreneurship, many MBAs, and many others. So I welcome you. If you're not part of Thai Silicon Valley or any Thai momentum, please come and join us. Our contact information is here, and we are so privileged and humbled to be contributing to Dr. Dasher's series here. Thanks and big shout out to the team from ATMC as well, Brianna and Kimberly and others. And the floor is all yours. We are humbled to be listening to this talk as well.
Thank you very much, Ajay. And let me encourage you to be looking forward to the beginning of May when Thai runs its big ThaiCon conference, the largest conference in the world about entrepreneurship, where I think something like 6,500 people gather in person and over 50,000 people are participating worldwide. So thanks very much for your cooperation with our program today. So we're very fortunate that in many ways around here, but one of the key people who is really guiding the government of India's semiconductor mission is Dr. Arogyaswami Paulraj. And Professor Paulraj is chairing several committees for the government of India about building up a semiconductor industry. So he's a perfect person to speak in our series. Professor Paulraj was on the active faculty in engineering at Stanford from 1993 until 2013, and he continues with us as Emeritus Professor of Research at Stanford. He's well known for core technologies in wireless communication, especially MIMO, multiple in, multiple out. And this is really at the core of 4G and 5G wireless networks. He has received many prestigious awards for his work. Just this year, he received the Royal Academy of Engineering Prince Philip Medal. And last year, he received the IET, the Institute for Electronics and Telecommunications Faraday Medal. He's received the Marconi Prize. He has received the Alexander Graham Bell Medal. He was named to the U.S. National Inventors Hall of Fame in 2018. Before coming to the U.S., he was in the Indian Navy. He rose to the rank of Commodore, which is equivalent to Rear Admiral in the United States Navy. And he was responsible for developing an anti-submarine sonar in the 1980s that at the time was the most advanced in the world. So we're very fortunate that Professor Paulraj would be able to spend some time and talk to us about what's happening in India to build up the semiconductor industry. Professor Paulraj, the floor is yours.
Thank you for coming. It's a lot of crowd. Stanford is really messed up with our alumni day. I believe the first time inviting all alumni every campus, and every year. And my daughter, who's active in the, said that there's no accommodation left in the hotels now. So, so anyway, so thank you for coming. Thank you, Richard, for inviting me. I'm involved with the Indian semiconductor industry, so let me share where we are. And so let me start with the Indian economy. It's good to put the whole thing in some perspective. So we are about 1.43 billion, I think the most populous country in the world. Our GDP is about 3.95 trillion. So we are now global rank 5, and I think probably very soon global rank 3. So that's good news. I think the best news is we're still growing rapidly. I think at least 7%, if not more. The most numbers are between 7 to 7.5. That's excellent. And but we do have the problem of per capita GDP. We're a large population, so it's about $2,700 per year, and our global rank is very low. So that actually is the area that India has to improve, increase our per capita GDP, and certainly, I'm sure, the focus for all of us here. In terms of sectorial GDP, agriculture is 18.4%. But it employs, I think, almost 45% of our population. Industry is relatively low for a country like India, 28%. We need to do more. China is much higher. And services has been the strength of India, and it's about 53%. The highlights of India, many of you know this, is that we've done very well in software and engineering services, particularly software. I think software, our total revenue is about 200 billion plus, and at least 100 billion is export. So it's been a big factor in India's growth and wealth. Generic pharma, so pretty much most medicines that I take or you take is from manufactured in India. The generic pharma, we tend to buy the base chemicals from China, but we do the formulation in India. We have a big industry. Auto is doing very well too. Mostly foreign automakers, except for Tatas, but we have a strong industry in autos. So those are the strong points. The lowlights are jobs. Now, we really have a problem with jobs. It's very good in southern India, but northern India jobs are really a problem. I think the government is moving its focus to do something about it. Manufacturing has been, despite I mentioned these things, we're still pretty small. Certainly electronic manufacturing is a big target now. Manufacturing has not been great. Labor participation is not great. Again, South is always doing well, but the North is not good, particularly for women. And we still have extreme poverty, less than $2 a day, 18% of population is extreme poverty. So we have a long way to go, but there's, I think, lots of hope. So room for a lot of optimism. There's a lot of political will. Mr. Modi has been focusing on indigenous technology and self-reliance. We've been a very big force. Now, I've met him many times. I think a change in mindset, see a lot of optimism in India. It's increasing every month now. So it's great. The digital public infrastructure is extremely valuable because now everybody has a cell phone. They all use MIMO. And you know, it really connects the poorest to the poor to the economy. So it's really transformative, and we have to thank Nandan and others who made it possible. And perhaps I'm not so pushed on this China +1. That is The US is trying to push things out of China, and some of it may land in India. But more than manufacturing, India certainly needs that, but we also need intellectual property. So I'll question that, but otherwise, political will, mindset, optimism, DPI are all great. And certainly physical infrastructure is also growing. Lots of things to be happy about in India. So broadly, semiconductors is part of what I call deep tech. So in developed economies, these are what NSF classifies as R&D intensive manufacturing, that you're moving atoms and not just bits, and large global market. Unless you have large global market, you can't spend time on R&D. If you don't spend time on R&D, you're going to be dead. So R&D intensity and large global markets is the crown jewels of any country. And the current areas are semiconductors and information technology, aerospace and commercial jets, branded new molecule pharma, advanced instrumentation, and software publishing. US revenue from this sector is about 1.5 trillion, and we are the dominant country in the world. If you look at the top line, I'm not talking about, you ignore the fact that we also also have COGS. Semiconductors, 40% of the world is in the US, branded pharma, 32%, advanced instrumentation, about 30%, and commercial jets, about 35%. So we're still the dominant country, but we do, of course, have potential threats. I'll talk about that later. But how did this come about in the US? I think it was an ecosystem of fundamental research, places like Stanford, translational programs to help move technology from universities to industry, risk-tolerant investments. The venture capital has done a lot of that, and certainly the government too has funded a lot of research through various programs, and so they've been probably the bigger than VC environment, the big pusher. And the government support in terms of policy. I mean, certainly the success of Qualcomm and Cisco didn't happen by their own strength. The US government has been a big part of pushing these things. And of course, always sustained by continuous innovation. Innovation and IP is the key, and it's the only way we can enter this industry and remain there. So US is the dominant player, but it's not challenged by PR China, people in China, which country which I know reasonably well. Certainly South Korea, Taiwan, Europe in some areas, but we still the big dog. So what about India? The deep tech industry and supporting ecosystem has not yet developed in India. India is not yet a part of the system. And one of the reasons is the Indian tech segment has been dominated by a government controlled sector. So manufacturing has been with public sector units. R&D, government R&D labs are the only labs really around. And research universities are also IITs, many of you are from there, and I myself from IIT Delhi, I did a PhD there. But these are government-controlled entities, and in general, we'll compare India to what happened in South Korea or China or with Taiwan or with even Vietnam. We've not been quite as successful. So, but for the past 5 to 6 years, Prime Minister Modi, I think, has been pushing on self-reliance and indigenization. And of course, when you talk about self-reliance, I think we all understand we can't be self-reliant. It's not a realistic goal. No country is self-reliant, certainly not in the United States. But the idea is to participate in this industry and take a share of it. That's what India needs to do. And of course, we're now moving to the private sector because we know the public sector does not perform. And it's difficult because that has driven India for the last 50, 60 years, and it has not done well. So we're moving to the private sector, which gives us hope. And the current focus in deep tech is now in semiconductors and core ICT. Core ICT, I mean, servers and switches and wireless infrastructure and so on and so forth. And of course, this area is absolutely the foundation for every economic segment in India. Economic, security, and societal. And of course, we also have a growing import burden. The numbers from, I think, most countries, but certainly in India, vary all over the place. You look at Reserve Bank of India, or look at the World Bank, or you look at Indian meat internal numbers, they're all over the place, but 62 billion import may be a good number. So that's fine. So India has not yet entered deep tech. We need to. but semiconductors is our first thrust. So let's talk a little bit about the Indian fab industry. Well, we first started in 1984. We set up a Semiconductor Complex Limited in Punjab, in Mohali. I think briefly I was ex officio on the board for a few months before I think I moved to Stanford. We got 5-micron technology those days from collaboration with American Microsystems. It was doing fairly well. We were doing kind of watt chips, very low-end chips, but it had a very good design team. I know many of them. I later on hired them in my companies here in the Silicon Valley. Very good design team and a fairly good fab team, but it was a public sector unit. So in some sense, it was doomed. And in 1989, we had a fire, and then we shut it down. So I think in 2005, it was converted into a lab under the Space Department. It currently has a small team. I've been there recently with 180 nanometer technology. There's no real commercial activity. So they were restart attempts. I was a little bit involved, but 2010, there was a major restart attempt with $5 billion budget. Mr. Petroda was running it. There was an empowered committee, but it didn't take off. I wouldn't go into the reasons for it. So it really didn't, government didn't really put any money down. So today, as a result, we have no domestic capability in India, either Indian or foreign headquartered in fabs. So fab manufacturing, we don't have any activity. And so we now launched the Indian Semiconductor Mission. The initial investment is $10 billion. So I'll talk about that now. So what about the fabless industry? So this started with Texas Instruments Design Center in Bangalore in 1983. And I was, at that time I was at Stanford, but I went back in 86, I think I went back in 85. I started the AI lab for the government. And TI was just beginning at that time. They were in Miller's Road. Some of you may know that in Bangalore. Yeah. And it's been growing. So the multinational companies or foreign headquartered companies operating in India have grown like weeds. We have grown from Bangalore to Hyderabad to Pune to Noida. I'm not trying to push something into Chennai. And also we have had Indian headquartered companies, mostly US VC funded. And but most of them get to some point and get acquired. So I know all of them. I'll mention the list later. So they never grow beyond 50, 100, 200 people, and they get acquired, mostly because it's much easier for these Qualcomms and Broadcom to pick up these teams because they're much better trained and go and hire them in the market. And none of these companies actually survive as an Indian headquartered company. So where is the industry today? Foreign headquartered multinational companies run design centers. We have about more than 50, well more than 50 companies. All the big people from certainly from US are there. The number of count of engineering headcount is about 210,000 probably, something plus minus around that. And the total revenue billing, the only thing we get out of it is the payroll and probably for the rent for infrastructure is about $20 billion. It's a lot of money, but it's still pennies compared to what the companies which do the work in India, they make 100x more money out of that because we only get payroll, we don't get the value of intellectual property. So in Indian headquartered companies, in fabless, there have been design services to MNCs. It's been Wipro does a little bit. TCS has done something. I think Infosys also. $50 million of revenue. I think it still continues, mostly on the low end side of the spectrum. And product companies, right now, there are about 30 startups. I'm involved with many of them. So these are all fairly small companies. I'll talk more about it later. So the Indian fabless history has been more positive than the fab side, but I think it's really grown in Indian headquartered, but foreign headquarters has done extremely well. I think something like 20% of chip designers are sitting in India. And typically the head of Qualcomm R&D will just typically be my student, and from Stanford, the current guy is Dhananjay Gore, Dr. Dhananjay Gore at Qualcomm. So what about the third element is really manufacturing, electronic systems manufacturing. In fact, the government has been very focused on this till recently. So now semiconductors has also come to the fore. So this has been growing, and but still small. It's much smaller than China. It's probably only about 5 or 10% of China. Foreign headquartered, OEMs and ODMs. I think that terminology is extremely flexible. But Nokia, Ericsson, Apple, Samsung all have manufacturing in India. And the ODMs, Wistron, which I think is powered by Tata, Foxconn, is pretty big, Electronics, Sanmina, and many others. So there's plenty of these ODMs operating in India. And there are a few pure manufacturers that have no design component to it. Some of the ex-Taiwanese companies are all operating. They're fairly small. But their share of manufacturing is 95%. 95% in India are foreign-run companies. Indian headquartered companies, there are a few, and some of them are coming up quite well. Dixon, which I know well. Tata's has also entered into it. And VVDN is another company. So small, 5%. They tend to end on, they do kind of box and build, they do PCBA, but obviously, there's a lot more to manufacturing than that. The government has launched a scheme called the Production Link Incentive Scheme. There are many schemes, but this is the flagship scheme, where we give a subsidy of 4 to 5% on incremental sales up to 5 years. And the idea there was that a lot of manufacturing went to Vietnam and even Thailand and Malaysia because the cost of manufacturing was lower there for a variety of reasons. I think mainly infrastructure, I think, was stronger there than we had in India. So we would give this viability gap funding to help bridge that gap. And so that's, I think, a big part of what's happening. Its question mark is whether how successful it is. That's something to look at. But let me pick up the phone manufacturing. We do a lot of phone manufacturing in a sense that because the big guys are Samsung and Apple. They do a lot of phones. I think the Chinese companies also build in India, Xiaomi and all these people. So today, in some sense, almost all the phones we use in India are essentially manufactured in India. But the issue is that our value addition is pretty low. Local components are typically only metallics and maybe some PCBAs. Metallics, I think, for example, the back cover of the, I think the steel cover of iPhone, for example, is made by Tata's in India. And maybe some of the RF shielding inside the phone. It's probably total value add in a typical phone is about 7% from components. Labor, factory management, real estate, security, we add about another 8%. But the components are all imported. I mean, the real components. Semiconductors, obviously, displays, batteries, camera, precision components, about 85%. So when we say things are made in India, we probably contribute about 10 to 15%. The rest of it is imported. And this has been a big factor in our current concern in India because this is where all the value is and we're not being able to add value. In fact, I was in Bangalore recently in a conference called to look at this issue of the components issue, not only semiconductor, but even beyond that. I mean, batteries also has been hard to break into. After all, this is the commercial market, and we only break into if we can be cost competitive and performance competitive. So manufacturing remains, I think, I mean, it's progressing, but it's also a challenge. So what about the Indian Semiconductor Mission? Some history, I actually came to Stanford. I joined as a postdoc in 1991. Then I became a research professor in 93, I think. Krishna will know it more than I do. But I tried to decouple from India for various reasons. I mean, very little contact. What little contact didn't work out. But 2018, 2019, I got involved. I went to India about 10 times, met with almost all the senior people, including the Prime Minister, saying we have to do something about semiconductor because this is really so critical for the country from a variety of viewpoints. So, but my thinking that time was that we should get a lot of outside people from the ecosystem involved, that is people who work in the industry involved, to help formulate the policies. The PM approved, but finally they did launch 2 years later, but it's still run by the Indian bureaucracy within the ministries. But they are reaching out. For example, I'm involved with this whole process. So the fab side, we are looking at front end and the back end fabs, and also compound, semiconductors, display, and there's a fabulous piece I'll talk about later. We have now announced current investments. I was recently with the government, met with, this is a big meeting. We had about 50 CEOs from around the world in Delhi, and some of us met today in the morning with Vaishnav, and some of us, a few of us then later met with the Prime Minister. So the big deals are Tata's, who tied up with TSMC in Taiwan, which is a reasonable player in Taiwan. And they're doing a front-end fab, the target 28 nanometers, and it's going to set up in Gujarat. Next one is Tata's, assembly and test and packaging facility in Assam. Third one is Micron, the US company setting up assembly and test packaging, a captive plant in Gujarat. And there's a company called CG Power working with Renesas, setting up a specialized chips in Gujarat. I don't know too much about that. And there have been a little bit more in smaller investments, a few more in the pipeline that I know about. We have probably already committed, central government has already committed $10 billion to these projects. And in general, state governments, 50%, typically it's 50% commitment from the US, from the central government, and it's pari passu basis. Basically, whenever the company puts money in, we will then match it. 25% state, Gujarat and Assam, mostly in kind, land, infrastructure, power, and so on and so forth, and the balance by the promoters. So the big news here is Tata's really come in. I'm glad Chandra has done that. They put a lot of money into it, so they have now really becoming a powerhouse. And there's some also other good news about them, I'll tell you. But this is the first major Indian company really taking risks in this area. That's good. So what about the prospects of fab industry? I think the tailwind is that the government is committed. I think this time the Prime Minister himself told us that he thinks this will take 2 or 3 decades, and that's the right way to look at it. It's a very tough journey. It's going to take time. And of course, the Indian ecosystem, anybody travels to India, the ecosystem improving in terms of, I mean, certainly for fabs, land, water, communications, transport. I must say Gujarat's done a good job. And so obviously the fabs feel confident of going there. Assam is setting up, they're setting up also an OSAT facility. So it's improving, and general infrastructure in India has really grown. Our roads have done well, airports, air travel. So it's India's really providing ecosystem. It's also China +1, which I'm always skeptical about, but it's probably more to serve US interests, not necessarily Indian interests. And certainly, I think the big news is no more government entities, no more public sector undertakings, because it's very hard for them to perform. So it's going to be in the private sector. Of course, headwind is a lot of headwind. The global industry is increasingly consolidated. Just 2 companies, NVIDIA and Broadcom have, 4 trillion market cap or whatever it is around that. And so it's getting more and more consolidated. So new entrants is going to be really, really tough. And also the industry is moving towards higher tech nodes, 2 and 3 nanometers. And there's still money to be made in the lower tech nodes, but it's extremely competitive there. China is going to dump chips at a very low cost. And also for India, everything is new because we don't have a history here. So the huge learning curve ahead in terms of production line skills, technology, business skills. But we have hired Randeep Thakur originally from Applied Materials, who will be the CEO of Tata Electronics. And I think we're hiring more people. I'm sure we're going after people from this room also. So it's a good thing we're taking people back from here for these fabs. And the other headwind is that there's not, except Tata, there's not much as yet. I think Mr. Adani is also looking at it. I was supposed to meet him a week ago about putting money into the area. So I think the Ambanis have not, but Adani is looking at it. But Tata's have already put money down. But in general, 2 or 3 billion is small. This thing takes hundreds of billions of dollars. So it's still a long way to go, but it's a start. What about fabulous industry? Ford headquarters, I mentioned, it's with 200,000 engineers. We do pretty advanced chips, Qualcomm or Broadcom does the frontline chips there. So no shortage of skills, but it's mostly engineering. We don't do product management very much. Marketing, all that is done over here, but engineering is done there. It's also a walled garden. There's a lot of expertise there, but it doesn't come out into the country because it's all IP. So what they do, it stays inside, and it doesn't fertilize the broader economy, a broader ecosystem. And the value I mentioned is about $20 billion in payroll. What about Indian headquarters before today? Mostly VCs in here, particularly Liputan. Now, all of you know, I've also served on my boards. He had funded companies, but VC funding here is drying up for startups, except probably for AI chips. So basically, they also withdrawn from India. So that phase has gone away. But they did fund about 7 or 8 companies. Most of them got acquired. Total acquisition M&A value was about $270 million in the last 10 years. This is pretty small. So what about the Indian headquarters current? Mostly the private sector is withdrawn. One company, one firm called Peak 15, I think Sequoia is a Sequoia outfit. So they've been funding a little bit, $1 million, kind of very, very small. And I think Celesta, which I work with a little bit, I think we too will write some small checks. But the main funder is government, a design link incentive scheme under the ISM. I'm the chairman of that. We also have funding through the Ministry of Department of Technology. I also chair some of that. So we have a bunch of government funding going in, mostly seed money. It's pretty small. But we have probably funded by now about 20 companies between ISM and CDOT. But also I wanted to mention there's been some really good success in India in wireless, and I've been pushing on it for many years. So some time ago, the government decided that BSNL, which is the government carrier, will only get a 4G license if they use Indian technology. And good enough, Tejas is a company some of you may know, originally funded from here, from the US, but they'd gone IPO. They were building optical boxes, but they went into wireless. They had a very brilliant CTO, Kumar Sivarajan. And so they actually had built a 4G infrastructure, and they were selling into Borneo, in small villages in Borneo. But government, they got a huge order, 100,000 base stations plus order, and they delivered 70,000 base stations. So today they are among the biggest players in the world. So we have 4G infrastructure out of Tata's bots at Tejas now in the network, and it's no mean effort. I mean, no doubt semiconductors is all imported, but getting that kind of infrastructure up is great. So it shows what can be done.
How about SATCOM?
What?
Patrick, sir.
Oh.
How about SATCOM?
How about?
SATCOM. Satellite. I mean, Elon Musk has a Starlink.
Yeah. So what about India's SATCOM?
Yeah.
Indian, I think.
ISRO. They have.
Yeah, let's hold the questions until the presentation, okay? Thank you.
So what about Indian headquarters fabulous? I want to talk a little bit about that. So where is our support or tailwind for it? The government is committed for the long term, I think, for surely. And they, in fact, want to put more money, and I've been selling them too, because the government can only write a check, but, if the money comes from, they put no skin in the game, and they don't take both positions. So it's only dumb money. We need venture capital to come in who understand the industry, who can put money, put skin in the game, and then really make sure these guys succeed. But the government is committed to lots of energy and enthusiasm. I pretty much know almost all the startups in India, and sometimes too optimistic, I would say, because we know how hard it is here. And I know the industry here, and I've always worried about India, but nevertheless, it's a start. Most of the money government is still seed money. It's pretty small. And it's amazing how people survive in India with that kind of money. But good technical skills, I would say. Some of it leaks from the MNC shop. People quit the Qualcomm and Intel outputs and trying to start something. But still the understanding of other things may not be great. So headwind, the global industry is again highly consolidated. I mean, in the top 3 or 4 companies, they control 70% of the revenue. So it's hard to enter here now. And global VC funding is shrinking, and certainly it's shrunk a lot in the US. Look at the right-hand side. China probably is the biggest funder of venture capital. I mean, mostly done through Alibaba and not through individual firms, but as VC companies, but only through individual firms. The US is pretty small, Israel is smaller, and ROW is not great. But so venture capital is shrinking. It's very hard to, build in wireless, particularly where I'm active. There's no way I think it's hard to fund any company anymore because we can't take on Qualcomm or Broadcom, and they just dominate the stuff. And VC funding in India is negligible. I mean, there's no VCs except one small guy. And so that's a big challenge, and something I'm very focused on. And also a huge market, huge learning curve because, product management, finding the niches. Here, as you know, when you do a startup, you're running around in circles, looking for some traction somewhere, and most things fail. Finally, you hit something, and then it works out. So that kind of mindset of finding that niche is not there. The belief is we build something, somebody will buy it. It's going to take time. And basically, it's not well connected with the global ecosystem. Certainly, much of it is here. It's not well connected to Silicon Valley, which again is an area we need to work on. So how do we actually improve? I'm going to stop fairly soon and leave time for questions and interaction. How to improve the fabulous, Indian headquartered fabulous segment? I mean, I'm very focused on this. I mean, the foreign headquarters needs no help. They're doing very well, but we need Indian headquartered companies. And so it's crucial for the government for some policy initiatives from the government. We started, but we need to evolve lots of policy. And this is where I'm focused on, but I'm also getting old. We need to attract VC funding at scale from mature ecosystems where people bring industry knowledge, which often means bringing money from Silicon Valley. And many countries have tried this. I mean, I'm aware of measures taken in Singapore and in China and in South Korea also. So we need a lot of measures to attract venture capital. They'll only come if they can make money in India easier than they can make money here. So we need to do a lot there. The government has to provide policy support for that, and there are many things we can do. Second thing is to connect our companies in India to external ecosystems. Again, it's mostly to here for mentoring. Israel did a lot. Partnerships, board expertise, market access, and also attract talent. So these connectivities are right now very low. So my focus really is to try and improve this. And I think very important to attract experienced entrepreneurs to start companies. Any of you who have done 2 companies, particularly who has failed in one, we need those people back in India. Particularly failures, we all learn much more from failures from successes, but you will bring back a whole lot of advantages over what we find in India, because in India, people, I mean, there's always exceptions, but people are still take a very simplistic view of how difficult this journey is going to be. Then I think also market protection. Market protection is very difficult semiconductors for a variety of reasons I won't go into. So this has to be done very, very carefully. And one thing we're trying to focus on is can you create some niche markets in India where the local companies have a kind of first move advantage before they get competition from outside. So all this needs a lot of industry knowledge and very deep thinking. The government has to put effort into this. And IP is another issue. When you do a startup, nobody bothers you. But when you go 100 million plus revenue, you're going to hit by lawsuits. And it happened to me. So India is not there, but it will face it at some point in time. Also, we should look at acquisitions. It's difficult, but why not acquire companies? Because we avoid the whole lot of attrition that happens in startups and try and get there faster, but companies are getting very expensive. I mean, a company with good revenue is very, very expensive now to buy. So I think the challenge for India is government policy. We need a lot more work to understand the nuances of the industry and shape policies to make it successful. I don't think we need government money. Money, I think, will come, but policy structure is important. So, finally, I mean, no doubt a tough journey, but India must and can build a deep tech industry. I mean, we're talking about leading with semiconductors, but all of this is important. Commercial jets, pharma, instrumentation. You know, we are a large country, a lot of talent. So we must, and I think we can build it. I'd say I can do it from my own background. I'll tell you a little bit about it. And my goal my personal goal in Indian headquartered semiconductors is about 2 to 3% of global market. In 10 years, the global market will be about 1.2 trillion probably. We're now about 610 billion. We'll probably double in the next 10 years, maybe more. Maybe 30 billion of value addition in 10 years. That'll be a good stretch goal for India. And hopefully two or three companies in the global top 30. So that will be something, but not easy, but something we should look at. So why should India really look at these things? One thing I could say is there's enormous talent base in that country that can join the global innovation ecosystem. Indians today are not part of the system. I mean, MNCs, yeah, we do tap into talent there, but we need Indian companies to join this ecosystem. There's plenty of problems to solve globally. So the talent that we can bring is enormous. We certainly should lift India's per capita GDP and also balance of power. We have now a very strong growing power to north of India, China. And it's a tough world, and this world power matters a lot. And if India also becomes more powerful, I think it will keep Asia peaceful. We need stronger growth in India. So I'll end with that. So a little bit about my background. Some of you may not know it, but I was in Indian Navy I was in uniform for 30 years, but in actual service for 25. I spent about 10 years building Indian sonar systems. My second system, APSO, was probably the most advanced system in the world. And these sonars are massive systems. They're not small. And those days in the 70s, there was no AI, there was no semiconductors either, very little, no wireless. Sonars were considered the deep tech because of Cold War and nuclear tip submarines. And India actually built a system which was, in my opinion, the best in the world. We're certainly far superior to Soviet Union or to Europe. And then I spent a brief time in the US at Stanford doing some math. I went back and started 3 labs. Those 3 pictures are there. AI lab, and then a lab on computing, CDAC, and then one on military electronics. These are large campuses now. When I did it, they were pretty small. I was supposed to take over the combat jet program at CA, but that's the reason finally I had some differences with the government on autonomy. And so I came back and joined Stanford as a doctoral student. And then Stanford, it's been my more for 20 years. And right now I sit on committees. Thank you. With that, I'll take questions.
Well, Professor Paulraj, I'm going to take executive privilege and kind of ask the first question. So in understanding semiconductors, they are in one sense end products, but they don't create value unless they're put into things, the electronic systems that you talked about. So kind of based on your question, right, about satellite communications, what do you think are, I'm taking it in a different place. What are the kinds of applications that you think Indian semiconductor should really focus on?
So I think so if you have a chip, somebody has to buy the chip.
Right.
It means somebody who's building the platform, whether it's a phone or whether it's a set-top box, has to accept your chip as the most competitive chip for that. So that's a tough journey. How do you do that? So in some sense, the barriers for India and normally any startup is how do you get on the platform? And those platforms are extremely difficult to get into. So that's a good question. So ultimately, it is when an Indian company has a product which is competitive in performance and cheaper, or it's more expensive, but certainly much better performance. So that's a good question. The thing is that India itself cannot actually build. Right now, we don't control any platform.
Yeah.
None of these platforms are controlled. They're all coming out of China or from the United States, mostly. So, and some of that will happen slowly. For example, we're now doing 4G infrastructure. So I think as that builds up, that will provide some pull. But Indian industry will have to look at foreign platforms.
Yeah.
And so we have to compete and win. It's a tough journey, can be done.
So I do remember that 12 or 13 years ago when Brazil decided they wanted to really build up their semiconductor industry. At about the same time, the government passed a rule that more than 50% of the components of a cell phone had to be manufactured in Brazil. Do you think that kind of thing will happen?
Yep. So the thing, of course, is, pretty about 85%, maybe if you take out batteries, which still very, because China's pricing is so difficult to meet that we're not being able to grow our industry in India. But still, 60% is semiconductors, and it's all getting into 2-3 nanometer nodes, or maybe 7 nanometers, maybe you can get into 12. But India is not going to do that quickly. So it turns out, particularly consumer electronics, it's not going to be within India's reach to get on this platform because it's very difficult to get into that. So the answer is, you say 50%, that's not going to happen. By the way, our value addition in phones today is much poorer than it was 25 years ago when we were building Nokia phones. At that time, there was only one IC, there were lots of discretes, a lot more. So we had a big ecosystem for that. But now it's shrunk because it's getting more and more deep tech.
Okay, thank you. So I have one more question. And this is actually kind of picking up one of our questions that came in on Zoom from Sandra. A couple of things that you didn't mention about needs that India has to develop. One would be the natural resource side. Is there a concern about whether there's enough water, especially? And then the second one would be education. Do you think that there will be enough education, not only to train the people who are actually developing new processes and controlling fabs, but all the people that will have to do maintenance and all the people who will have to be involved in the bigger supply chain?
So, I mean, I'm just focusing only on answering the semiconductor aspect of the question.
Right.
Yeah, water, I mean, this always comes up immediately, water and reliable power. I believe, now that Tatas have been doing a lot of footwork, and so I think it is we're setting up plants in Gujarat. I think it's pretty safe there because we managed to get it done. So, I mean, we still haven't started production, but I believe that one can believe that we are there, we're getting there. So, I mean, the issue really is very, very pure water. We need extremely pure water, but I believe that's been looked into. And by the way, I think we've brought in a lot of Japanese companies, other companies to help with some of these things, gases. So a lot of footwork has been done, so I'm not too concerned about it. But the skills at the production line, that is, I think we will get some help from and PSMC, but that's something we've got to do. And I sometimes feel that is really the critical thing. I think the success of TSMC in Taiwan has been really the consistent skill levels on the fab floor. They keep people for decades and nurture them. So we have a lot of learning to do, but my thinking is it can be done. So we have to be hopeful.
Okay, have to do it. Okay, so let's open the floor to questions. Could I ask a student in the class for the first question? Somebody who's here. If not, you have the floor. Go ahead.
Thank you. I don't believe I agree with your characterization that semiconductor chips are just nothing with it, unless there's some other product to add value to them. Would you say the same of gasoline engines, motors, any other kind of technology? In fact, it is my opinion that the world would grind to a halt, come to a grinding halt, as happened during COVID.
Okay.
Okay, that was just a comment. Thank you. My question.
Thanks for your comment.
Yeah, my question.
It's an important comment because certainly you can't have these things without semiconductors, right?
Yeah, thanks.
It's as much my opinion as Professor Paul.
So when I met the Prime Minister this time, I told him the world runs on semiconductors.
Yes, it does.
So
for quite a while, vehicle production in the US came to a standstill or almost a standstill because there's shortage of chips. So, yeah. But I have a question for you, Dr. Paulraj.
Yeah, quick one.
Quick one. Okay, this is kind of a involved one. Sorry. It's about Morris Chang and TSMC. What is it that prevents a similar scenario from happening in India? Let me finish one more half a minute. I listened to a lot of NPR. I heard the whole story of Morris Chang, how his girlfriend went to Canada for graduate studies and he wanted to follow her. He went and followed. This is a true story. And he did not know how to speak English, but eventually he made it here. And then he realized I can take away a lot of talent from Silicon Valley and go set up the thing in TSMC in Taiwan. And he succeeded. Now he's become the biggest. What prevents?
Let me answer the question. Yeah, so I think, by the way, Morris Chang is, I think, a Stanford PhD, so
yeah,
note that. But, you know, we have Randeep Thakur, so we hope he will shape up in a Morris Chang.
Yeah, wait, who? You have
Okay, I think we should move on to other questions. Okay, thanks. Actually, I saw your hand early. Yeah.
Thank you, sir. Based on the experience with the Indian semiconductor mission so far, I wanted to get your wisdom on whether batteries and storage technology, energy storage in general, would be the next ambition for the government to also focus on and bring in the ecosystem. And if that's the case, how do we do it? In general, what are the other deep tech, large manufacturing requirements that as a policy focus, the Indian government should be on?
Yeah, so I think in the deep tech list I mentioned, I think right now it's semiconductors. When you say storage, you're talking about power storage?
Yes, energy storage.
Yeah, energy storage, I think as yet, you know, there are huge number of options there, but India is talking a lot about hydrogen, green hydrogen. But there's been nothing significant there, but we're doing very well in solar, you know, PVs, knows much more than I do, but we probably have 120 gigawatts now, and I think we will build another 200 gigawatts in the next 5-6 years. So plenty of solar, but storage, and even wind is doing quite a lot of wind, but storage remains, I think it's difficult to solve here, not completely solved here either. So that remains a question mark. But in terms of deep tech, the list I gave outside semiconductors is the current focus.
I think I'd just like to add to what Professor Paulraj mentioned. I'm Commodore Dr. Rana. I was in the Indian Navy for 33 years, part of the design team, design aircraft carrier and the warships, and nowadays I'm helping startup community at IIT Delhi. Just to answer your question, if you just watch the events taking place now in the energy storage sector in India, they are becoming very, very aggressive by virtue of the fact that the number of conferences being held. One is there on November 28th. If you'd like to participate in that, maybe.
Okay, thank you for your comments. I'm seeing all kinds of hands all over the place. First, I want to pull a couple from Zoom. Several people mentioned that there are venture capital options for semiconductors in India. A couple of people who are directly involved in the industry commented, but it is small. But the best question on Zoom about this is that government policy and VC usually don't mix.
Yeah.
Government policy and venture capital usually don't mix. How do you encourage the kind of venture capital industry?
Yeah, and venture capital companies that I know of, I've only seen 1 or 2 companies putting money in. I'm talking about foreign headquarters. Indian headquarters is one small company called India, but very, very small money. So I'd like to know who else is active from US. So I certainly would like to know about that.
Well, we got comments from Silicon Catalyst.
Good.
And we also got a comment from Semi-IX at IIT Bombay.
I'd love to hear from that. Sure.
Yeah, okay. So,
Second question was?
basically that government policy doesn't usually do well in kind of, semiconductor industry is very independent.
Yeah,
The VC industry is very independent.
It's an industry there to make money. The only reason they invest is to make money. But nevertheless, I think at least, I dealt with a lot of VCs. I'm part of that world now myself. Sometimes they bring very little value beyond the check, but sometimes they do bring value. And but the government itself cannot bring any value because they don't understand the industry. So I think the path to Indian fabless is through, has to come through venture capital. And you got to attract people and make it worthwhile for them. Right now, my general impression is it's very, very small.
Okay, so I'm seeing hands all over. You go first.
I really appreciate it. Yeah, so my question is, I have been from this semiconductor world, working on a lot of companies, having my own company. And right now I'm trying to help more the startups in India. The problem that we are facing is that most of the people, they have a very, very cushy jobs in multinationals. They don't want to quit. That's number one. The second thing is there's no VC system around it. Government give 1 to 2 million, but a typical fabless costs like 50 to 100 million to start it. I just want to know how we can break that ice and get into like one key fabless startup in India, because there's no capital intensive there. It's mainly intellectual property. I want to hear from you, like what can we do from it?
Yeah, so I've been constantly after. I've only had only 2 students from me from Stanford who are worked in India. One was Agarwal, who did Qualcomm, and finally, maybe partly my persuasion, left and started a company, and it's called Nature. They raised in 2021 at a market cap of 800 million, so it did very well. I haven't tracked them recently. I'm initially sitting in San Diego. So I do go after people saying, why don't you come out and start a company? But the really good ones are so handcuffed with options. They've got to leave millions of dollars options on the table. And we all know how hard it is to succeed in startups. So they feel that options, it doesn't look good. So that's where the problem is. It's just too difficult to leave that kind of money on the table and walk away and then struggle to build a company. Very, very hard.
Thank you. Claude, you go next.
25 years ago, Americans essentially kickstarted the semiconductor industry in China through design centers, factories, investments, et cetera. And then the US government was essentially not involved. And then one day, the national security establishment woke up and said, oh my God, this is terrible for the United States. What would you say to our government in the US about, how would you explain to them that we could support your efforts? That this is not a replay, 20 years down the road, we will be sorry.
I'm skeptical of any government supporting, in my opinion, no government, nobody wants to transfer technology because they will become another China and compete against you. So I'm probably skeptical on that, but ultimately, what can the government do? They can, most of these, in my opinion, most of these agreements are not worth very much more than the paper they're written on. It's really, if the capital in this country, I'm talking the US, and the skill set in this country believes they can make money in India, then they'll go there. So the Indian job is to attract these guys, saying that you're going to make money here. So I think that's the only way it's going to work. I'm very skeptical of government policy, US government enabling anything. My 2 cents.
Thank you. Go next, please.
You raised 2 points. One was a water, another was a power. And since I belong to that sector, and incidentally, the professor also knows the Indian conditions. My question is that we, on water availability front, we are not short. We have abundant. But when it comes to dedicating, because we know intersectoral problems, which you have raised, and interstate and lower riparian issues. So you need to have some kind of a dedicated storage, both for water and for power, because we have a number of pump storages going on stream in our country now to make sure that we are able to handle the wind and solar. So I want to know that keeping in view the our conditions of India, what kind of a dedicated power and water storage you will envisage for each setup or each fab?
I think you might be conflating. I mean, the overall water position in India, that's a complicated thing, and I think we can do more there. But a fab does need water, but it's a tiny, tiny amount compared to what India has. So it's so water and power are efficient, are critical, but it's a matter of investing. Obviously, I think I have no front-end knowledge, but I don't think Tata's, I mean, they have lots of good people, would have taken those bets, or Renaissance or others, without being sure they can get that. So I think that footwork has been done, and they are pretty confident that they will get what they need for the fabs.
Can I follow up on that a little bit? Because it has to do with the handoff between where you actually make things happen from the government and where you provide a government subsidy and let the private sector decide whether or not they can build a fab in this location. In some ways, it's better if the government really looks at the money and makes it attractive for a company to come in, but the company is going to have to be responsible for making sure they have the resources, right?
Right. So in fact, they have to put 25% skin in the game.
Right.
So it's my 2 cents would be that Tata's, they're a huge company, a global company. They have done the footwork for it. I can't vouch for it, but Tata's have invested on their own more than $2 billion.
Yeah.
A lot of money.
Yeah. Thank you. Go ahead. You're next.
Thank you. Thank you, Professor, for sharing. Very insightful. My name is Sanjay, and I ran the CHIPS program here in US. Not all of it. Some of it with my colleagues.
On behalf of the Department of Commerce.
Yes, as Senior Director in Department.
But which one?
Department of Commerce CHIPS program.
The CHIPS Act.
The CHIPS Act. The
CHIPS Act. Okay.
Yeah. So just like similar to India's PLI CHIPS Act. So I have some observation that, whatever it's worth. So I'm the fund that India has 10 billion. So I worked on hundreds of applications, underwrote more than 15 billion of investment here in US, and built a fund of $500 million to invest in the startups. So that fund is, so India has like 1 billion under the production design link scheme, 10 billion under the production link scheme. And the fab cost, it's about $25 billion, 40K wafers on the advanced nodes. But it doesn't go that far. That's one. And the second is, in terms of, there is fabs, but there is more to this ecosystem than the fabs. Packaging substrate, very high quality capacitors, connectors, and so on. Without this, the whole supply chain doesn't, conclude. And if we think of the allied ecosystem, all the areas have different strength. Japan has strength in tools and so forth, and Europe has some strength, America. So to build this allied ecosystem, I don't know whether the money would be better spent building that kind of things, which are not there. So for example, in the bill that was passed, substrates were not included. So substrates don't get 25% ITC. India can play a big role over there in building the substrate. Similarly, I can go on the list that are missed from the CHIPS Act and that we could do over here in India.
Substrates. There's another question coming in on Zoom, by the way, about manufacturing equipment.
Packaging substrate.
So so let me address your. I'd like to talk to you later, but almost any fab player in this country, in the world today, whether it's TSMC or Global Foundries, is telling India is going to build a fab. They're skeptical because it's so difficult. But nevertheless, my thinking is we have to start, and we don't have all the answers right now. But India is a huge country, large population. It's got a lot of talent. So my thinking is, let us try. We may not entirely succeed, but I think not trying is not an option. We have to try, and we have a lot to learn. But I do believe, and I worked in India, we put our minds to, we can do things. So the United States itself, as you know, we're struggling now with lots of issues, at least on the fab side. So my response is, let's begin. And I do agree that it's a tough journey and so much more to learn. But unless we start, we will not learn.
Okay, excellent. I think back in the back, you had a question.
Yeah, thank you, Professor, so much for the great talk. As someone who's relatively new to the industry, the headwind that you pointed out that resonated the most with me had to do with the learning curve associated with building these fabs. And, Intel's copy everything ethos has kind of permeated the industry. And I'm wondering if some of the challenges faced by India might provide an opportunity for innovation in specifically the organization and orchestration of fabs, as opposed to maybe copying what Intel did 20 years ago and putting themselves kind of directly on that path. I was wondering what your outlook is on.
Look, on the fab side, I won't be able to really respond. I don't understand that industry at all. So, but on the fabless side, the slight response is that, technically, India can build a chip and get on some platform if it's competitive cost performance, and that's really tough. But so I've been trying to see whether we could create some niche applications, which, for example, IoT around 5G, we've done very little in this country. I mean, China done much more. There's much more opportunities around that. So maybe a lot of these companies are not focused on it. We can try and define an application, get some thinking going there, and then try and pull some semiconductors into it and give these small companies a chance to build there. So, therefore, I agree with the point saying that just copying what is done before is often the difficult part. We have to think differently and think innovatively.
So coming in on Zoom from a long-term friend of our Senator Sheridan, he points out that China began by buying older fabs and then kind of got trained on low-margin consumer products. Now, not from Sheridan, but from me, as Japan is trying to rebuild its semiconductor industry, they're taking extreme technical challenges to go to the most advanced chips immediately. Where on that spectrum do you think India should be?
So, I think the fab that Tatas are putting up, which is really the
okay.
thing. I think it's 28 nanometer, maybe the end goal. We're probably starting at 60. So we are starting at the pretty low end, yeah.
Okay.
But it's not I think the equipment is going to be new. PSMC is helping us with the technology. And I think we are buying quite a bit from Japan this time. It's not necessarily all from Applied Materials and all that. So we are diversified the source of equipment. And the answer is not a second-hand fab, a new fab, but definitely a very modest target.
Okay. Go ahead.
My name is Dinkar. First of all, I wanted to thank you for sharing your perspective. There's very few role models for people who successfully navigate helping two countries and their economies. So a lot of us want to do that, but don't actually end up doing that. So thank you for sharing. My question was about R&D blind spots. You called out 4 or 5 sectors that were deep tech, and I'm sure there are others emerging. Naively, it looks to me that in the US and in China both, large companies with a lot of resources, of variety, different types of resources, successfully are leading innovation in certain types of things. LLM models is one good example, which is very capital intensive. So it's like startups are not designed to do really, really capital intensive R&D, right? So the Indian corporate sector, like in all of the sectors you listed, except software publishing, is kind of missing. From branded pharma, it's missing. From semis, it's missing. LLMs, it's kind of missing. So is there a structural issue in large Indian companies where they're not able to really excel at R&D? And like the problems you're encountering in semis, are they broader than just semis? Like, and how should what's your opinion of what should be done about that?
Very good question. One thing is, I sometimes joke that the success of the software industry actually down in India because it is much easier to make money And it involved no risk, almost zero risk, and involved no IP. There's no IP in these companies. And it probably sucked all the talent away. So in some sense, that's probably slowed there, because building technology is very hard, very risky. So it's probably slowed that effort over here. Going back to the big corporates, Tata's, Reliance, I think Adani's have come up, and there are others also, L&T. I think, they're all, I mean, Tata is not listed, but they're all companies which, have to survive. And I think they came to the conclusion that deep tech and certainly semiconductors is very difficult to enter. So just couldn't take the risk. So in some sense, I got a feeling, I think it's even true in our country here, the government has been a force behind it. So India, the government has to step up, but do it very carefully, because the free money means, it's going to be disaster. We got to put people's skin in the game, and sure, I think Tata's the first time I think Tata's really stepped into technology. So it's a good start, but we need others to come in. I wish Reliance was doing more here. I know them well, but nevertheless, Reliance is a listed company, and they have to be careful.
So kind of as a follow through on the investment side, you had mentioned venture capital. What do you think about investing in public companies? So are there ways that India should be encouraging foreign investors in public sector companies? This is kind of coming from KB, who's one of our Zoom participants.
Investment in publics?
Yeah, public stocks.
Stock.
Yeah.
Okay. You mean
to encourage the growth of the semiconductor industry through, say, investment in.
But since there's no Indian headquartered companies in this area, you mean investing money into foreign companies?
Yeah.
I think that would be hard for the government to. Well, then if government becomes investor, I think that doesn't usually play well in any country. So because they're going to, when the stock market goes down, they're going to get trapped. Okay. So I think that's not an option.
Go ahead, Prakash.
Yeah. In a recent presentation on Wall Street Week, a very interesting point was made about the space industry in the US transitioned from giving specs to the large manufacturers like Boeing and Lockheed to giving a destination or a target and letting the industry come up with solutions. And the example they cited as a very good example of success was Anduril down in Southern California. Will that model work in India?
You're talking about in fact,
procurement, for example, for the space sector or for the military or whatever.
There have been 2 or 3 space companies come up, which was one of them. So they're all doing kind of, vehicles for LEO orbit type of vehicles. And I think 1 or 2 are doing satellites too. Still pretty small. They raised a fair amount of money. And in fact, they may actually got more VC money than semiconductors. I mean, for some reason. So ISRO doesn't really get involved with them, though I think you might. In fact, one company I'm involved with, I've been telling them to hire some ex-ISRO people. They still haven't done that. So I think that's been somewhat organic. Government has not been that much involved. But for some reason, Indian entrepreneurs have been launching vehicle companies and getting money funded. They're still not commercially successful. So that's happening. One company that I know has got the first time in the world, a fully 3D printed engine, which seems to be working well. So, yeah, so that sector actually is doing well, the space launch sector. But semiconductors, it's a different story.
Okay, so I've got to call executive privilege one more time and ask the last question. What do you think are the biggest opportunities for us here in Silicon Valley as a result of the growth of the industry and the semiconductor industry in India?
No, technology is transferred by people. So people from here who have done companies, gone through, all the midnight knowledge that I used to do before. Seen a lot of setbacks and seen successes. They have an enormous amount of value for India. Go back to India and start companies. You'll do well.
Okay, that's a good note for us to end today's formal session. We will have an outdoor reception about 200 yards away from here, starting in 10 minutes. So I'm sorry, we have to end the session on time. So we'll finish the session and continue our discussion informally.
Not a discussion.
So thanks, everybody, and thanks very much.